Hi everyone and welcome back to Module 4 of Networking Fundamentals. Let's go ahead and check our agenda and get started here. Alright, so just a couple of quick things to go over in this module. We're going to focus on understanding media types, right? So we're going to talk about twisted pair cables and also fiber optic cables, right? So the cables that connect devices all over the globe and help make up the internet. All right, so wired networks, right? They're really important. As wireless connections are easily accessible and as widely used as they are, we still depend on wired networks to send our data. Because even if you're using your cell phone, right? Well, your cell phone is connected to a wireless access point, and that wireless access point is probably connected to a wire, right? A switch. Now, the most common type of wire used through our networking is made up of copper, and that's called a twisted pair cable, right? And then the cable that we rely on to send our data at a very long distance at very fast speeds is made up of glass fiber, and that fiber transmit data by way of light. Before we discuss fiber optic cables, let's talk for a little bit more about twisted pair cables, okay? Now, twisted pair cables, once again, are commonly found, the most common in fact. And the reason being is that they're very cheap, right? They're pretty fast and they're really efficient at sending data by way of electrical pulses. We've got multiple types of twisted pair cables that are available, and they can be installed temporary or permanently. Each twisted pair cable has 8 wires, okay? And those wires are grouped into 4 parts. Now notice here in my example, we have a brown pair, we have a green pair, we have a blue pair, and an orange pair. Now notice within each pair, you have one that's solid, and then you have one that's, well, I guess you can call it striped, right? Now each pair is twisted, and that's in order to reduce something we call crosstalk and interference. Now, we then surround all those twisted pair cables with a plastic jacket that typically gives us that quintessential blue look that you see on a standard Ethernet cable. Alright, so patch cables are these cables that we use to connect one device to another, or one device to an RJ45 port, right? Each end of the patch cable is terminated with an RJ45 plug using a cabling standard. Now, there are 2 different types of patch cables that we're going to briefly talk about. They're called straight through cable and also crossover cable. All right, so these cabling standards that we're going to touch on, they're developed by the TIA EIA, right? The Telecommunications Industry Association and the Electronic Industry Alliance, right? Now, when making a patch cable, the twisted pair cable are placed in order, right? And that's the standard. The order is defined, right? Now, and we use this device that you see on the right here. It's called a crimper. We use that for a process that we call crimping, right? And that's to secure our wires into the RJ45 connector. Now, note here that that's placed down, trying to secure the cables into the connector, right? And then we crimp it or we secure it once the wires are in place. All right, so let's detail some of the cabling standards. We've got an older version, the BOGB, right? And then we have 2 that are most commonly used. We have 568A and then 568B. Now notice here that I have 2 modules up on the screen for you. 568A follows a very specific pattern where you have the white and green, then white and orange, and then solid blue, then white and blue, and then solid orange, and then the white and brown, and then brown. And then B is a little bit different, okay? What you're going to see is that the blue cables are in the same position, right? And then the brown cables are in the same position, right? So blue occupy 4 and 5, and then brown always occupies 7 and 8. The only thing that's different here is that the orange and the green are swapped between 568 and 568B, okay? So we use straight through cables to connect PCs or other devices that we use every day to a central connecting device, right? And a straight through cable is the most common type of patch cable. We also call it straight through because it uses the same standard. Now, crossover cables are used to connect like devices, right? Such as a computer to a computer, right? And they're called crossover cable because of the fact that if you start at one end with the 568 standard, it crosses over to the other end to the 568B standard, right? So very easy for you to understand. Now, as we mentioned before, there are some limitations with twisted pair cabling, right? There's some interference with the twisted pair cabling. And they actually can run about 100 meters, which is about 300 feet, before they start suffering from something we call attenuation. Now, attenuation is simply the difference between the amount of information that's being transmitted and the amount of information that actually reaches its destination. Okay, so what attenuation is basically you're saying signal loss, right? You're losing data due to attenuation. Now, twisted pair cabling is also susceptible to interference, right? Now, notice that there are 4 different types of categories of twisted pair cables, okay? So note that you have category 3, which come before category 5, then category 5, which came before category E, then category E, which comes before category 6, right? And then notice here on this chart how the maximum speed rates, right, the data transfer rates or bit rate are increasing with each new category. All right, so we talked about interference, right? But what is interference? All right, all it is just anything that can disrupt or modify a signal that ultimately will result in the corruption of data. Right? There's a couple of different types of interferences. We have electromagnetic interference, you have radio frequency interference, and then crosstalk. Now, electromagnetic interference can be given off by a microwave or anything that transmit electromagnetic fields, right? And what that can do is essentially throw off these electronic signals that are being transmitted along a wire. And similar to that is the radio frequency interference, because radio frequencies can interfere with wireless communication. And then finally, you have crosstalk down here, and crosstalk actually occurs within the Ethernet cable. And so if you're sending data on a twisted pair cable and receiving data on another twisted pair cable, there may be some crosstalk that occurs where the electrical signal on one copper starts to get mixed up with the electrical signal on another one. And so crosstalk happens, and it can definitely lead to data corruption and attenuation. So we can combat crosstalk with shielded pair cables, right, or shielded twisted pair cables. Not just crosstalk, but general interference can be addressed through the use of shielded twisted pair cables, or STP cables. And all we do is wrap each pair with an aluminum shield, and then we put all of those pairs back inside of a plastic jacket. Now, keep in mind that shielded twisted pair cables are typically a little bit more expensive than unshielded twisted pair cables, right? We also have certain types of cables called plenum rated, and these types of cables are installed inside of a wall or above drop ceilings, like you might find in a school, where they can be hurt by a sprinkler system or a lighting system or things of that nature, like an electrical system, right? So plenum rated cabling is important because if there's a fire, these cables have a Teflon coating that protects them, right? They don't give off a high amount of smoke, okay? And they're used in these situations because a standard twisted pair cable have a PVC jacket, which can actually emit really deadly gas and which make it really, really dangerous in a fire situation. So you definitely would want to use a plenum rated cable, right, for anything that happens to be near electrical work, right? You certainly wouldn't want to cause any more hazard that might already occur during a fire, right? So keep that in mind. All right, so fiber optic cables, right? The last part of our cabling journey. Fiber optic cables transmit data using light instead of electricity. Now, we commonly call them fiber, but they're actually made up of glass or plastic, right? Because, well, fiber is made up of glass or plastic, right? They have an incredibly higher data transfer rate, and they're used in situations where high data transfer view rates are required, right? They also are used when data needs to be transferred at longer distances. That's because data can transfer the speed of light, which is really, really fast, right? You've heard of the speed of light, right? It's also traveled, as I said before, at longer distances because light can travel much longer or at a much longer distance than electricity before the signal degrades, right? And that's why it works so well. Right now, because of this, it happens to be a little bit more expensive in some circumstances. There are a couple of different modes with fiber optic cabling. Now, this can be a little bit confusing, so do make sure that you're paying close attention right now. Now, there's single mode, and it actually just carries data through a single ray of light, right? And then the light is, in this instance, is created by a laser, right? Now, it's used for much, much longer distances, like 10 kilometers up to 80 kilometers, which is really, really far, right? This type of fiber optic cabling is used to send data across oceans, right? That's just mind-boggling. And then there's multi-mode fiber, right? Multi-mode is a larger fiber. There's a larger fiber density, and it actually carries multiple ray of light. And the way that this happens is that LEDs are used in order to beam light at different angles in order to transfer the speed, right? And this allows you to send multiple data streams on the same fiber, right? Now, this is also used, the multi-fiber is also used for shorter runs, right? So it's just 600 meters, which is still a lot longer than any typical twisted pair cable. So that's something for you to be aware of. All right, so thanks for joining me. Let's do a quick recap of our agenda here. We talked about twisted pair cabling, right? Unshielded twisted pair cabling and shielded twisted pair cabling. And we also touched on plenum rated cables as well. And then we briefly talked about fiber optic cabling and a couple of different fascinating aspects about how it's able to send data at a really fast speed at a really high rate. All right. So thanks so much for joining me, and I look forward to seeing you in the next module. Bye.